Hi guys, welcome back to my channel. Today we'll be going through another challenging H2 A-level physics question. So let's get straight to it. So this is the question. Basically, you have a spherical surface and there's a ball placed on top of the sphere given an initial velocity u. So the question is, and this ball starts to roll down the surface. So the question is, at which angle theta does this ball lose contact from the surface and just fall down? So let's solve it. The first thing we have to understand is that um, when the ball loses contact from the surface, normal contact force is zero. So N equals to zero, the normal contact force. So let me just draw it for you. So basically, at each point, there is a normal contact force. I'll call this N. Oops, sorry. What happened to the line? So normal contact force is basically zero, and that is when this ball loses contact. And so, what is um, so the main question is what is keeping what is giving this normal contact force that we see over here? And the answer is the weight of the ball plus the centripetal force needed for the ball to move in a circular motion. So if we draw both these things, um, so you have the weight, the weight of the ball, which is this way. This is basically W. Sorry, it's basically W. Sorry, I'll just draw it properly. Oops. You have W, and there's a component of W that acts towards the center of the sphere. So you have a component. Let me just to have a dotted. I don't know if I can have a dotted line. You have a component of W acting towards the center of the sphere. So I'll call it WC. So you have weight, you have the component of weight acting towards the center of the sphere, plus because this ball is moving in circular motion, you also have the centripetal force. So I'll draw another arrow. You have centripetal force that must be given um, to the ball so that it continues to move in a circular path on the sphere. So you have um, F C as well. So basically, there are three forces acting on the ball. One is the component of weight towards the center of the sphere. And then second is because of circular motion, there is a centripetal force also towards the center of sphere. And lastly, the normal contact force acting on the ball by sphere. So the equation is basically, so I'll just put the component of weight as WC, centripetal force as FC, and let me just zoom in a bit, and the normal contact force as N. So the equation you have here is um, so the equation you basically have is WC, which is the component of weight along towards the center of the sphere, plus the plus the centripetal force equals to N. When N equals 0, WC must equal equals to minus F of C. Um, sorry, actually, I made a mistake here. Sorry. Um, so the centripetal force is not actually a force. It is basically a force that we need to make it move in circular motion. So actually, it comes in the right side of the equation. So it's like this. So basically, um, the weight provides for the normal for the centripetal force, and any extra force would be going to the normal contact force. So this is how it looks. So when n equals 0, the weight component of weight must equal to a centripetal force. When this condition is fulfilled, the ball loses contact. Okay, so first we have to find out what is the component of weight towards the center of the sphere. So if you look at it, this angle is I'll just erase a few things. I'll keep erasing a few things until this angle here is sorry. This angle here is also theta. So if you look at it, hmm, um, sorry, give me a second here. Yeah. So basically, um, this way and then yep. So basically, when basically W of C must equal to W cosine theta. Sorry, not cosine. Sorry. Yeah. Sorry. Yeah, correct. It's W cosine theta. So why is because I'll just draw a thing here. I'll just draw a diagram here. So you basically have weight acting downwards. You have sorry. You also have You also have the component of weight along the center towards the center, and you also have this. Sorry, and sorry, I just need to draw this. Um, how do I draw something? So this angle here is theta. So we have this is W, and this is theta. This is basically theta. This is W, and this is WC, and this is a right angle. So as you can see, W cosine theta W cosine theta must equal WC. And we also know that cosine theta is basically okay. So first we need to understand what are we trying to calculate here. So what I'm trying to do here is get. So you have like this, and I want to find out what is. So if we have a height like this called h. Sorry. Yeah. So this is h. Um, so cosine theta, because cosine theta is basically this over a hypotenuse. So this part over the hypotenuse. So so the adjacent part is basically r minus h divided by the hypotenuse is r. So r minus h by r. So if you rewrite the first equation, WC is equal to W times R minus H divided by R. Then we need to calculate what is the centripetal force. And if you have studied circular motion, you know that the centripetal force is basically um, mv square by r, where r is the radius of curvature. So in this case, this r is basically just this r. like this, the radius of the sphere. So you have mv squared by r. So now, because we have to equate wc with fc, we equate them now since we have expressions for both. So we have w times r minus h by r is equal to mv square by r. Okay, but the problem here is that we do not know what is h and we do not know what is v. So we need to at the very least we need to get what is um, we need to solve for one of the unknowns, and so we need to solve for v in this case. So what is the velocity of the ball at the moment it loses contact with the surface? So for this we use energy considerations. So basically loss in PE equals gain in KE, kinetic energy. So loss in PE is basically mgh, which is equal the gain in KE, which is half mv squared. So we cancel out the m. We make v the subject. So we have from this we have v is equal to where is the square root? Okay, I'll just put it like this. Square root of 2gh. Yep. V is basically equal to square root of 2gh. So substituting into 1, we get sorry, actually we don't even need okay, never mind, never mind. So we have w r minus h by r equals mv square m mv square by r. So what is v square? V square is basically 2gh. So that's why I think we could have just left it as v square. You don't need to take the square root of it. So you have m 2 mgh by r. So and then mg is basically equals to v. So that is right. Mg equals to w. So it's m mg equals to w. So we have canceling W on both sides. We have R minus H by R equals 2H by R. So then we we write H in terms of R. So we have by rearranging equation. So we have um we have R equals 2H by R. Sorry, we have yeah, you have sorry, we have R equals to 3H by R, and then H is basically equals to R squared by 3. I think so. That doesn't make sense. Sorry. I think there must be a mistake somewhere. Hmm. Oh, okay. Sorry. Is actually this is a bracket. This is a bracket. Sorry. So we have R R minus H by R. Sorry, R minus. So we multiply both sides by R. So we get R minus H equals to 2H. R equals 3H. And H equals R by 3. So this is H. So to find theta, so basically we found that this H is equal to R by 3. So this H is equal to R by 3. So we still have to find out what is theta. So theta is basically R minus H by R. And H is R by 3. which equals to r, sorry, r minus r by 3 divided by r. So we have 2r by 3 by r. And which is basically equals to, yep, it basically equals to 2/3. Is equal to 2/3, yep. So this is the answer. So yep. Um, so I hope you have understood how to solve this question. Um, if you have any further questions of about this particular topic, or you want me to cover any other questions in AL physics, please write in the comments, and yeah, I will try to cover them in the next videos. Thank you for watching this video. Thanks.